Given that the sine of A equals 2 over radical 13 and the cosine of B equals 1 over radical 5, and angles A and B are both in the first quadrant, find the exact value of the sine of the quantity A minus B in simplest radical form. So we are going to continue using our angle sum and difference formulas that we've already talked about. In this case, we're just going to see maybe some more difficult problems in terms of the algebra that follows. So we have the sine of A and the cosine of B. A and B are different angles, but they are both in quadrant 1. So I'm going to draw two different triangles, right triangles, one that represents angle A and one that represents angle B. And then we can solve for any missing information there. And then we can find the sine of A minus B. So let's say in this triangle we have, this is angle A. If the sine is 2 over root 13, then that's opposite over hypotenuse. And over here, if this is angle B in our right triangle, then the cosine is 1 over root 5. So that's going to be adjacent over hypotenuse. I know typically we don't like to leave our answers with radicals in the denominator. Sometimes the answers or the given information will have that, but your answers should not. So just keep that in mind. So let's first figure out what our missing sides are in each triangle using the Pythagorean theorem. So in this case, we could say x squared plus 2 squared equals the square root of 13 squared. So x squared plus 4 equals 13. Therefore, x squared would equal 9. So that missing side is going to be 3 units long. So we'll label this one 3. And then over here, 1 squared plus, let's say, b squared equals the square root of 5 squared. So 1 plus b squared equals 5. Therefore, b squared equals 4. And so b, or the other side, equals 2. So we have all of our side lengths. This means that when we are going to evaluate the sine of quantity A minus B, we're going to be using this formula up here. So that means that the sine of A minus B is equal to the sine of the first angle, so the sine of A, times the cosine of the second angle, so the cosine of B, minus the cosine of the first angle times the sine of the second angle. And since we have all sides labeled on these triangles, we are able to fill that information in. So the sine of A would be over here, angle A. The sine would be opposite over hypotenuse, so 2 over root 13, times the cosine of B, which would be 1 over root 5, minus the cosine of A. So here's A. The cosine would be 3 over root 13, times the sine of B, so opposite over hypotenuse, 2 over root 5. So our job here is really just using algebra and making sure that this looks, it's completely simplified, it doesn't have any radicals in the denominator, things like that. So let's go ahead and follow order of operations. So if we multiply these fractions first, we get 2 over the square root of 13 times the square root of 5 is going to be the square root of 65. Minus, if we multiply these, 3 times 2 is 6 over the square root of 65. So it's good that we have the denominators are the same, so we're able to go ahead and subtract those. So 2 minus 6 is going to be negative 4 over the square root of 65. So we need to check two things. The first is, does the square root of 65 simplify? So if we were to try to figure out, okay, 65, if we divide 65 by 5, and you can use your calculator if you want to do that, but 65 divided by 5 is 13. So 5 times 13, these are both primes. So I'm not going to be able to split up this radical into a product of perfect squares. So I know that the square root of 65 does not simplify any further. So that's the first thing we have to check. The second thing is the radical in the denominator. We need to rationalize it. So remember, we need to multiply by 1. So we have to pick the same thing on top and on bottom. Since this is just a monomial, we can just multiply by that square root of 65 on top and on bottom. So negative 4 times the square root of 65 over the square root of 65 times itself is 65. One final check to ask, is it completely simplified? So at this point, we're checking, does this number and this number have any common factors that we could simplify any further. But we know that 65 doesn't have 4 as a factor, or 2, so we are unable to simplify that any further. So this would be our final answer. Example 2, given that sine of x equals 3/5 and tangent of y equals 1 over the square root of 15, x and y again are in quadrant 1, find the exact value of the cosine of the quantity x plus y in simplest radical form. So again, we are going to draw in our triangles, and they have to be right triangles, one for each angle. So we have one for angle x and another for angle y, and we can solve for those missing pieces. So if the sine of x is 3/5, that's opposite over hypotenuse. And because I know my triangles, this is a special right triangle. It's a 3, 4, 5, so we don't even need to use our Pythagorean theorem here. The tangent of y is opposite over adjacent. So this is going to be 1 here, and then the square root of 15 here. So to find the hypotenuse here, we want to take 1 squared plus the square root of 15 squared, and that's going to equal c squared. So 1 plus 15, or 16, will equal c squared, and therefore c will equal 4. So the hypotenuse here would be 4. That should be enough information in order to figure out the cosine of the quantity x plus y. So we are going to be using this formula right here. This means that you are taking the cosine of x times the cosine of y, and then you are subtracting the sine of each being multiplied together. So the product of sine x and sine y. So let's fill in what we know. The cosine of x over here is going to be 4/5 times the cosine of y, which would be the square root of 15 over 4, minus the sine of x, which was given to us as 3/5, times the sine of y over here. Sine of y is going to be 1/4, so multiplied by 1/4. Following order of operations, we need to multiply before we subtract. So multiplying here, we would get 4 root 15 in our numerator over our denominator of 20, minus over here, multiplying across, we would get 3 over 20. So last thing we need to do is we need to actually subtract. We have a common denominator already, so we have 4 root 15 minus 3 over 20 in a single fraction. We need to check to make sure that nothing can simplify. So first I look at 4 root 15 minus 3. The square root of 15, that does not simplify any further, because if we try to do our factor tree, this would be 5 and 3. Those are both prime, so I'm not going to be able to break that up any further. And these are unlike terms, so I can't combine them. Then I would check to see if there's a factor of the top, meaning could I factor the top so that something up here would simplify with the 20 below. And in this case, I don't see anything that I could factor out of 4 and 3 so that we could actually simplify any further than it already is. So in that case, we would leave our answer just like this. That would be our final answer. And let's do, we will go ahead and do both of them on the back just so you can see these extra practice problems. So again, you're going to draw your triangles, one for A and one for B, and then we are going to solve for any missing sides. So if this is angle A, the sine of A is going to be opposite over hypotenuse, and then B, the sine of B opposite over hypotenuse here. Going through and doing the math, we could say that 3 squared plus b squared equals the square root of 10 squared. So b squared is going to equal 10 minus 9, so 1, which means b equals 1. So our missing side here is 1. And then over here, if we said a squared plus 2 squared equals the square root of 5 squared, this would mean a squared will equal 5 minus 4, which is 1. And so a also equals 1. So our missing side here is 1. So the sine of a plus b means we can use this top equation here. So it's the sine of your first angle times the cosine of the second plus the cosine of the first times the sine of the second. So the sine of a is 3 over root 10 times the cosine of b is going to be 1 over root 5, plus the cosine of a, that's going to be over here, 1 over root 10, times the sine of b, which is 2 over root 5. Following order of operations, we would get 3 over the square root of 50 here, plus 2 over the square root of 50. So adding those together, we get 3 plus 2, or 5 over root 50. And here's what you need to be careful of. We have a square root of 50 that can be simplified. 50 is 25 times 2, and 5 times 5 gives us 25. So the square root of 50 is 5 times 5 times 2, or 5 squared. So this turns into 5 root 2. So this is really 5 over 5 root 2. Then we can simplify that. You can choose what to do first. Either simplify the 5 over 5, or you can rationalize your denominator. But if you simplify 5 over 5, we get 1 over root 2, which we rationalize by multiplying by root 2 over root 2. And you get root 2 over root 2 times root 2 is 2. So this would be our final answer. I am out of time on this video, so I will do the last question on another video.